Ever since the launch of the first Tesla models, the idea of a truly affordable electric car has been one of the biggest desires of electric vehicle enthusiasts. Over the years, speculation, rumors, and small clues have pointed to the development of a compact and economical model capable of expanding Tesla's global presence. Now, this possibility is closer to reality with the emergence of the Tesla Model Q, a vehicle designed to be the brand's most affordable and that could redefine the segment of popular electric cars. The basis of this new model is an innovation strategy focused on reducing costs without compromising performance or efficiency. To achieve this, Tesla is betting on a new generation platform, combined with advanced manufacturing processes, such as gigacasting and an optimized structural design. These innovations not only make the Model Q cheaper, but also speed up its production, allowing the company to reach unprecedented volumes on its assembly line. What really stands out, however, is the impact that this model could have on the market. For the first time, a Tesla will compete directly with entry-level electric vehicles from other brands, such as the Chevrolet Equinox EV and the BYD Dolphin. The big difference is that, while many competitors sacrifice autonomy and technology to reduce costs, the Model Q takes a different path, maintaining efficiency and innovation that are Tesla's trademarks, but at a much more affordable price. Speaking of price, this is one of the Model Q's biggest surprises. With government incentives and Tesla's aggressive production strategy, the final price of the car in the United States should be below $5,775, making it the cheapest Tesla ever made. This not only expands the audience that will be able to buy a car from the brand, but also puts pressure on other automakers to review their strategies to compete with this new competitor. The production of the Model Q will not only be a milestone for Tesla, but also for the entire automotive industry. The factory chosen to bring the model to life is Giga Mexico, one of the most recent additions to Tesla's global empire. Strategically located to meet demand in North America and international markets, this facility was designed to be one of the company's most efficient hubs, reducing logistics costs and optimizing manufacturing processes. When it comes to affordable electric vehicles, design needs to go beyond aesthetics. It must balance efficiency, comfort, and economic viability. The Model Q promises exactly that: a compact vehicle optimized for urban use, but without sacrificing Tesla's signature visual identity. Initially, it was speculated that it would use an all-new platform, but the latest reports indicate that Tesla has opted for a modified version of the Model 3 and Model Y platform. This choice makes sense, as it allows the company to reuse proven components and a consolidated production infrastructure, reducing costs and speeding up manufacturing. The size of the Model Q also reflects this approach. At 3,988 millimeters long, about 15% shorter than the Model 3, it will be more compact and easier to maneuver in urban areas, putting it in the same category as subcompact electric vehicles, such as the Mini Cooper Electric and Toyota Yaris Hybrid. This reduction in size is not only a matter of convenience, but also a strategic move, as smaller vehicles tend to be more efficient, requiring less battery power to achieve good range. In addition, the Model Q will be significantly lighter. While the Model 3 weighs about 1,650 kilograms, the new model is expected to reduce this weight, making it even more efficient and affordable for consumers. By reducing weight by up to 30%, the Model Q should weigh around 1,160 kilograms, 2,554 pounds. This difference is crucial, as it directly affects energy consumption, allowing even a smaller battery to offer competitive range. In addition, a lighter car provides more agile handling, an essential aspect for a vehicle designed for everyday use in busy urban environments. Another interesting point in the design of the Model Q is its aerodynamics. Tesla has already demonstrated with the Model 3 and Model Y that a well-optimized drag coefficient can significantly improve vehicle efficiency. Following the same philosophy, the Model Q is expected to achieve a drag coefficient close to 0.23 CD, similar to that of the Model 3. This detail may seem small, but it has a real impact on range and energy consumption, especially at higher speeds. Visually, the Model Q should follow Tesla's latest design language, as seen in the updates of the Model 3 Highland and Model Y Juniper. This means a clean, minimalist style with aerodynamic lines and few unnecessary elements. The interior will likely follow the same approach, with simplified cabin focus on a touchscreen as a control center, eliminating as many physical buttons as possible. This strategy not only reduces production costs, but also reinforces Tesla's identity, which prioritizes digital integration in its vehicles. There is still no official confirmation about the materials that will be used in the construction of the Model Q, but considering Tesla's cost-cutting strategy, it is likely that the company will opt for lighter and more affordable materials without compromising safety. One point of attention will be the structural resistance of the vehicle in collisions, especially since smaller models can be more vulnerable to impacts against larger cars. However, Tesla has already demonstrated its ability to offer high safety standards even in compact models, making this an important aspect to watch when the first crash tests are released. In addition to the exterior design and structure, another factor that may influence the acceptance of the Model Q in the market is the use of interior space. Despite being a compact car, Tesla can take advantage of the absence of a combustion engine to optimize cabin space, ensuring comfort for occupants. Models like the Model 3 are already known for their efficient interior layout, and the Model Q is expected to follow the same philosophy, offering a functional trunk and a surprisingly large interior space for a subcompact vehicle. When talking about a more affordable Tesla, many might imagine that performance will be modest and autonomy limited. However, the Model Q aims to challenge this perception, balancing energy efficiency, responsive acceleration, and a range that surpasses that of many direct competitors, all without increasing the cost to the point of compromising its affordable proposition. But how does Tesla intend to achieve this balance? The answer lies in the choice of batteries and the optimization of energy consumption. The Model Q is expected to offer two battery options, both based on LFP, lithium iron phosphate, technology, known for its durability, lower production cost, and greater number of charge cycles without significant loss of performance. The basic version will be equipped with one of these batteries, ensuring an affordable cost without compromising the vehicle's reliability and energy efficiency. With a 53 kilowatt-hour battery and rear-wheel drive (RWD), the Model Q should offer an estimated range of approximately 310 miles (500 kilometers), surpassing the entry-level Chevrolet Equinox EV, which has a range of approximately 250 miles (400 kilometers). The all-wheel drive AWD version with a 75 kilowatt-hour battery could reach between 270 and 290 miles, 430 and 467 kilometers, slightly less due to the higher energy consumption of the all-wheel drive system. However, range alone is not enough. Recharging time is a key factor in the user experience. In this regard, the Model Q should maintain Tesla's competitive advantage by utilizing the company's V3 supercharger network. This will allow it to recharge from 10% to 80% of the battery in about 20 to 25 minutes, surpassing models like the Volkswagen ID.3, which needs approximately 35 minutes to reach the same level of charge. For those who opt for home charging on a level 2 charger, the Model Q should provide between 30 and 40 kilometers of range per hour charging, ensuring that most drivers start the day with a full battery. In terms of performance, the Model Q promises to be a positive surprise, even with its focus on affordability. Tesla has a history of offering agile acceleration even in its most affordable models. The RWD version should accelerate from 0 to 100 kilometers per hour, 0 to 60 miles per hour, in around 6.5 to 7 seconds, a very respectable time for a compact car and faster than the Volkswagen ID.3, which does the same distance in 7.3 seconds. The AWD version can reach this mark in less than 5 seconds, rivaling more sophisticated models, such as a Hyundai Ioniq 5 AWD. This level of performance, combined with reduced weight of approximately 1,160 kilograms, 2,554 pounds, should result in a dynamic and efficient driving experience, providing good stability in curves and comfort for urban traffic. The Model Q's biggest differentiator in the electric vehicle market may be its price. For years, Tesla has been criticized for not offering a truly affordable model, while maintaining a portfolio focus on premium vehicles. Now, with a target price of less than $25,000 after tax incentives, the company can finally deliver an electric car aimed at the masses, competing directly with popular models from other automakers. But how can Tesla reduce costs without compromising on performance and technology? The answer lies in a combination of mass production, more affordable LFP batteries, and a simplified architecture. Adapting the Model 3 and Model Y platform to the Model Q allows it to reuse already optimized manufacturing processes, eliminating the need to develop an entirely new production line. In addition, the car should benefit from Tesla's Giga Casting strategy, a technology that reduces the number of structural components and simplifies the assembly process, reducing costs and production time. This cost-cutting approach puts the Model Q in an extremely competitive position. The Chevrolet Equinox EV currently starts at around $28,000 after incentives, while the Volkswagen ID.3 costs around $38,000 in Europe. The BYD Dolphin, one of the most popular entry-level EVs in China, starts at between $22,000 and $30,000. With a more affordable price tag and Tesla's reputation, the Model Q could be a real game-changer in the compact EV segment. If Tesla can launch the Model Q for less than $15,770, it will not only be the brand's most affordable car, but also one of the cheapest electric vehicles available in the Western market. However, a low price alone does not guarantee success. To attract buyers, the Model Q needs to offer excellent value for money. With an estimated range of up to 500 kilometers, 310 miles, in the base version and compatibility with Tesla's V3 supercharger network for ultra-fast charging, the car already outperforms many direct competitors. The Chevrolet Equinox EV, for example, offers just 400 kilometers, 250 miles, in its entry-level version, while the Hyundai Kona Electric has a range of 415 kilometers, 258 miles. In other words, despite its reduced price, the Model Q can deliver superior range. Another decisive factor is the scale of production. Tesla plans to manufacture 500,000 Model QS per year, with a pace of up to 10,000 vehicles per week by the end of 2025. This volume is essential to keep unit costs low and ensure that the car's affordable price does not compromise the company's profitability. For the Model Q to become a true market success, Tesla will need to balance production and demand without compromising quality or costs. The strategy to achieve this involves the use of strategically located factories, advanced manufacturing technologies, and an optimized supply chain. The goal is clear: to make the Model Q one of the most produced electric vehicles in the world, with 500,000 units rolling off the assembly lines annually. At the heart of this strategy is Giga Mexico, Tesla's new factory that will be key to production of the Model Q. Its location was chosen to serve both the North American market and other international markets, taking advantage of tax incentives and reducing logistics costs. Furthermore, the proximity to Giga Texas will allow for a more efficient flow of supplies, avoiding production delays due to component shortages. However, Giga Mexico will not be solely responsible for this mission. Other Tesla factories will also play a crucial role. Giga Berlin in Germany will be in charge of supplying the European market with an estimated production capacity of 200,000 units per year by the end of 2025. This will speed up deliveries to European consumers and reduce import and tariff costs. Meanwhile, Giga Shanghai in China will focus on the Asian market with an initial volume of 100,000 units per year. This decentralized strategy will avoid bottlenecks in the supply chain and ensure that the Model Q is distributed globally without long waits. Another major differentiator for Tesla is its manufacturing innovations. For the Model Q, the company will rely on Giga Casting technology, which uses giant machines to fuse large parts of the body into a single piece. This method dramatically reduces the number of individual components and simplifies the assembly process, reducing costs and increasing efficiency. With fewer parts to weld and fit together, production time per unit will be significantly reduced, allowing Tesla to meet its manufacturing goals without having to overexpand its factories. Tesla has also invested heavily in its physical infrastructure and strategic battery supply agreements, ensuring that Model Q production will not be impacted by potential shortages of semiconductors or raw materials in the global market. Partnerships with suppliers such as CATL and local manufacturers ensure a steady supply of LFP, lithium iron phosphate batteries, which are more affordable and durable than traditional nickel manganese cobalt NMC batteries. This strategy not only reduces production costs, but also provides greater supply stability, avoiding the battery shortages that have already affected several automakers. Another key aspect of Model Q manufacturing is the optimization of Tesla's internal processes. Over time, the company has refined its industrial automation systems, allowing a large portion of vehicle assembly to be performed by advanced robots. This reduces the need for excessive labor, minimizes human error, and maintains consistent quality standard at scale. The result is a more agile and efficient production line, capable of delivering high volumes without compromising consistency of the vehicles manufactured. If there is one thing that sets Tesla apart from other automakers, it is its commitment to cutting-edge technology and artificial intelligence applied to driving. Even though it is the brand's most affordable model, the Model Q should not fall behind in this regard. On the contrary, it could become one of the most advanced models in the compact electric category, bringing features that many brands do not offer even in more expensive vehicles. One of the big unknowns is to what extent Tesla will implement its autonomous driving technology in the Model Q. The key to this may lie in the new HW5 hardware, the company's latest generation of full self-driving FSD computers. Equipped with a 3-nanometer processor, a significant advance over the HW4, this system allows for faster data processing and more accurate decisions in autonomous driving. In theory, this means that the Model Q will be able to operate fully autonomously in the future, provided there's regulatory approval. However, at launch, the vehicle is expected to come equipped with an advanced driver assistance package ADAS, including features such as enhanced cruise control, emergency braking, and automatic lane changing. Full self-driving FSD functionality may be offered as an optional feature, allowing buyers to choose between a more affordable model or paying an additional amount to unlock all autonomous capabilities. This strategy, already adopted in other Tesla models, could be crucial to keeping the Model Q within the expected price range. In addition to autonomous driving, the Model Q is expected to feature improved sensors and a more efficient computer vision system. Tesla has reduced its reliance on LiDAR sensors and radar, opting for a system based exclusively on high-definition cameras. This 360 degrees vision model will allow the car to interpret its surroundings with extreme precision, ensuring greater safety and efficiency in navigation. Another important technological difference in the Model Q will be its integration with Tesla's neural network, which continuously learns from the brand's millions of connected vehicles. This means that even after launch, the Model Q will continue to receive software updates via OTA over the air, improving performance, safety, and functionality over time. This ability to continually evolve is a major differentiator compared to other electric vehicles, which often remain with the same software throughout their useful life. The Model Q's control panel should follow Tesla's minimalist philosophy, adopting a fully digital interface. Instead of the traditional physical instrument panel, the vehicle will feature a large touchscreen in the center of the console, responsible for controlling virtually all the car's functions. Although this approach may be controversial for some consumers, it has already become standard in Tesla models, contributing to cost reduction by eliminating physical buttons and conventional panels. Finally, the Model Q's technology would not be complete without a full connection to the Tesla ecosystem. The car will be fully integrated with the brand's app, allowing drivers to remotely control various functions, such as preheating the vehicle, monitoring the battery level, and even activating the automatic parking system. In addition, the Model Q is likely to feature Tesla Vision, an internal monitoring system that detects signs of driver fatigue and issues alerts to avoid accidents. Following the trend seen in the Model 3 and Model Y models, Tesla may also introduce new entertainment and connectivity options in the Model Q. This could include support for video streaming, access to Tesla arcade games, and even integration with video conferencing platforms, transforming the car into a true entertainment center on wheels.